Hi everyone, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Leetcode contest. Okay, so we start. Can I just confirm? Can you just confirm once? Am I audible or visible or not? Okay, great. It seems there are very few people today, probably because a lazy winter morning, that too at a Sunday. Nobody is willing to wake up at 8 and give the contest, right? That's fine. So let's start. Okay, was the contest fun? How was the contest today for everyone? Like, was it easy, too hard? How did you feel? Okay, so people found question number two to be a bit difficult. Okay, fine. Even I agree with you all that probably that the second question was a bit more difficult than what a usual lead code second looks like. But okay, let's start. So let's start with the first problem and then we will see all of them one by one. So this was the first question. The name of the question is sum of variable length subarrays. Okay. The question says that you are given an integer array nums of size n. For each index I, where I lies between 0 to n, define a subarray num start to I, where start is max of 0, comma I minus nums I. Okay. And the question says that return the total sum of all elements from the subarray defined for each index in the array. What is a subarray? A subarray is a contiguous non-empty sequence of elements within an array. Okay, that's good. Now let's see what does the question mean. So this was the question. The question gives us as input. So the input is an array of elements. So the input is some array a1, a2, dot 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 an. Okay. And we need to output the sum of some specific subarrays which the question mentions. So what does the question says? The question says that you have this array, right? You have this n elements, a1, a2, a3, dot dot an. You loop over all I. So you start at a1, at 1, then you go to 2, then you go to 3, then you go to 4, till you go to n. And for every index, you have some special subarray. So how does it look like? So it basically says that if you are at some index I, so if you are at some index I, you basically need to pick the subarray which ends at I and starts at I minus AI. So it starts at I minus AI. Okay. So this is the subarray corresponding to the index I. So for this subarray, you will get some sum of elements. So you will find a sum of this. So corresponding to this, for all indices, you will get a sum and you have to find out the sum of all of them. So that is what our output is. Let me show what the questions mentions to be a sample test case and what we are expected to output. So it says that nums is 231. So let me take this. So our nums array is 231. Okay. Now start at I equal to 0. So this is our I equal to 0. When I mean I equal to 0, that means I have to start at this, I have to end at the 0th index. So this is my 0th index, this is my first index, and this is my second index. So I end at the 0th index and I take two extra elements here. But since two extra elements can't be taken, I just take up to here. So what is the sum of this subarray? The sum of this subarray is 2, right? So the sum of this subarray is 2. Basically, the value of the element in the of the index in the array, you have to take that many extra elements from the back and create a subarray. If you don't have that many elements, then no need to take them and find and take that subarray and calculate the sum for everything. So for I equal to 0, we get a 2. Now you move to I equal to 1. When you move to I equal to 1, what do you see? That means you basically need to take a subarray which ends at this index 1. And you need to take 3 more extra elements, but you are not getting 3 more extra elements. So just take how many you have. You have 2 and 3. So just take 2 and 3. And the sum of, and what is the sum of 2 and 3? It is 5, right? Just a second. Did I make a mistake? Okay, it's all right. Now I come to I equal to 2. So I come to I equal to 2. Okay, I think I wrote 0 here. It should be 1. Fine. Okay. It is 1. It is what is given in the input. So now I take 1. So when I equal to 2, I have to end the subarray at 2 and take 1 more extra element here. So that means I need to take this subarray, 1 and 3. What is the sum of this subarray? 1 and 3, it's 4, right? So that means this is 4. So for every index, we take some subarray and find the sum of it. And then finally, our output should be the sum of all these elements. So the sum of all these elements is 2 plus 5 plus 4, which is 11. So 11 is what is expected for us to give as output. Was I right? Yeah, exactly. It's 11. So everyone understood what the question is? Anyone with any doubts in the question? Okay, fine. So let me proceed with the solution then. So I think the question is clear. So what does the question mentions? So the question basically gives us, like in essence, like if you forget all those complicated stuff, the question basically gives us, so there is some subarray A1, A2, and times AN. The question picks some arbitrary subarray, which we do not know, which we will calculate from these values and stuff. But it gives some arbitrary subarray and it asks that what is the sum of it, right? So the problem is that what would be the brute force code? The brute force code is that you basically iterate I from 0 to n minus 1. And then you know what is the subarray. That's what is given in the question, right? So the subarray is J. So we basically need to counter, we basically need to take this subarray, right? It starts from I minus nums of I and it goes till I, right? We need to count this subarray. We need to count the sum of this subarray, right? So how can we do that? So the brute force approach would be just iterating over values of j. So just iterate j in this range and then compute the sum, right? So if you do that and then you can compute the sum, then the time complexity of the code is big O of n square. That is quadratic code, right? Because you have this outer for loop which runs n times, and then you have this inner for loop which in the worst case can again run order n times. So that would give an order n square code. So is it clear that why a brute force code would not work? Someone please confirm. Like a brute force would not work, right? Because the constraints does not allow. Okay, let's look at the constraints once. N nums dot length was given less than equal to 100. Okay, I didn't even see this in the contest. Probably then, since nums dot length was given less than equal to 100, even a brute force code would have worked. So that's, see, anyone who actually wrote a brute force here in the contest? Okay, I did not even see this. So yeah, exactly. Like since I did not see that the constraints were so less, so since the value of n was less than equal to 100, just writing a simple for loop, a simple nested for loop works here. Yeah, Shubham, you are right. It works. But what I did is, and I think probably many of you have this idea, and this comes very quickly in mind if you have seen this once. And that is the reason I did not even think of writing a brute force. So basically, when you are given a subarray, suppose you will be given arbitrary subarrays of an array. So you will be given many queries where you will be given arbitrary subarrays, and you need to find the sum of it. you need to find the sum of a subarray. Then what data structure can help us getting this in order 1 for some subarray? Anyone? Exactly, prefix sums. Okay, did anyone use prefix sums in the contest? Like anyone like me who did not see the constraints and used a prefix sum? Okay, great. So actually, instead of doing a brute force code, so a brute force code worked in order n squared time. And since the value of n was so less, I think n was given less than equal to 1000 or something in this problem. So even an order n square code would have worked. But what if the value of n is given as 1e6? If the value of n is given 10 to the power 6, then a big O of n square code would have failed, right? So big O of n square code fails. So in that case, what you can do, you can actually construct a prefix sum of the array. So this is a very handy data structure which will be helpful in many, many problems. You can actually construct a prefix sum of an array which will help you to find the sum of any subarray in order 1 time. So just quickly let me show what a prefix sum means. So suppose you have some subarray A, which is suppose these values 1, 3, 5, 2, 8, and 4. The prefix sum array of A is basically the prefix sum array of A is basically the value. So basically, you need to take the ith index of prefix sum. So basically, at some index I, the value at prefix sum would store the sum of the entire prefix of length I of A. So that means the prefix sum array should be something like this. It should be 1, it matches here. At the second index, it should be the sum of these two values. So at the second index, the value of pref should be 4. It should be the sum of these two values, 1 and 3. At the third index, it should be the sum of all these values, 1, 3, and 5. So it should be 9. At the fourth index, it should be the sum of all four values here. So it should be 11. So just like you can compute the prefix sum array like this. We can pre-compute a prefix sum array in order n time. Basically, just like write a for loop. So basically, write a for loop something like for I equal to 1 to n minus 1. And just do that pref I, that is nothing but ai plus the sum of all the previous values, right? So suppose this prefix I, this is basically this 2 and the sum of this entire thing, right? But then do not loop to find this entire thing as it would be still order n square. Rather, the sum of this entire thing is already stored here in the previous prefix index. So what should be the value here? It should be nothing but the value here in the previous index of pref and the current value of A. So 9 plus 2 gives you 11, right? So it should be simply AI plus pref I minus 1. Okay. So by doing this, you can actually make a prefix array of A. So how does making a prefix array help to find the sum of any subarray L to R? So suppose I have some subarray L to R and I need to find AL plus AL plus 1 plus dot plus AR. And suppose you somehow know that, okay, a prefix sum may be needed. So you compute the pref array. Now, how can you find this thing in order 1 time using the prefix array? Anyone knows the expression? People who solved it with prefix sums. What should be the sum of the subarray L to R? Exactly. So basically the sum of this subarray from L to R would be nothing but pref R. So it should be pref R minus pref L minus 1. It is quite easy to see, right? Like suppose you have some array. So you have some array A1, A2, and you have this subarray some array created, and you need to find the sum between two indices L and R. So this is L, this is R, and you need to find the sum of this subarray L to R. So isn't this, so the sum of this subarray L to R, that is basically the sum of this entire subarray from 0 to R minus the sum of this entire subarray from 0 to L minus 1, right? So, and the sum of this entire subarray from 0 to R is already stored in pref R. So this is stored in pref R, and this value is stored in pref L minus 1. And you can actually, this is stored in pref L minus 1. So you can actually remove, or basically you can say that sum of LR, that is nothing but pref R. So that gives me the sum of all values till R minus pref L minus 1, things which we do not require because those are not part of the L to R subarray. So we can use this to actually compute the sum of any subarray in order one time. So once this prefix array is computed, what you can do, you can make a loop I from 0 to n minus 1. And for every index, you can very simply compute the sum which is required with the subarray which is mentioned in the question in just simple order one time. So the time complexity of this code would be order n. So even if n would have been given 10 to the power 6, then our prefix sum code would have passed, but then our brute force code would have not. Okay, so anyone with any doubts? Anyone with any doubts in the prefix sum part? Anyone who did not know this before? And did you understand? Okay, a short rewind. Sure. So basically, if you look at the first question of today's contest, it basically asked to find the sum of some subarrays. So there were n subarrays given for each index I. They had a special way of so basically they gave an array a1, a2, an, and for each index I they had some weird subarray which you need to find the sum of. So there was this subarray which you need to find the sum of. What was the subarray that is given in the question? Now, so for each index, you have to find this sum and then you have to find the sum of all these sums. So the brute force approach would be just iterate over I, and for all subarrays, just compute the sum. That would be big O of n square, right? But today, in today's contest, the constraints were just so less that even a brute force code would have passed. So for today's contest, from the perspective of today's contest, this prefix sum approach is not at all required even. But I said that, okay, if the value of n was too large, say suppose the value of n is 1e6, then how would you solve the problem? Because then a brute force code would have not worked. So the simple idea is making a prefix sum data structure, which will help you to find the sum of any arbitrary subarray in order one time. How so? Because if you have a subarray, because if you have a prefix sum array, pref calculated, then the sum of LR, then the sum of L to R, that is very simple, that can be very simply written as pref R minus pref L minus 1. This is very easy to see because the sum of any subarray L to R, the sum of any subarray L to R, that is basically the sum of the entire prefix of length R minus the sum of this prefix of length L minus 1, right? So if this entire sum, if you just remove this part, then what you remain is with this subarray L to R. So that was the logic. Okay, is it fine, Vetha? You asked for a rewind? Okay, some people actually mentioned a very good point. So Priyansh said that if L is 0, then we actually do not need to take this term. And he's right. Like if L is 0, then you basically, then if you use this formula, then this would become pref 0 minus 1, pref minus 1, right? So since pref is an array, this would give errors. So if L is 0, then you simply do not need to subtract this. Just take the value of pref R. Just that works because pref R already stores the value of the subarray from 0 to R minus 1. So let me show the code quickly. Okay, so this is the code for this. I took n is nothing but the size of the nums array. Pref is the prefix sum array, and then we have computed the prefix sum. And after that, I've just basically take this L. So L is the leftmost index of the subarray corresponding to I, which is max of 0, I minus num psi. Nothing new. I've just copied it from the question. It says that it max of 0, I minus num psi. That is our starting position. And then I just add pref I minus pref L minus 1. And I subtract the pref L minus 1 as Priyansh correctly mentioned when L is greater than 0. And finally return the answer. Okay, so is it clear? Exactly. Even that can be done. We can have pref 0 as 0 and then we can start the prefix sum technique. There are many ways of implementing this. So I hope it's clear, right? I know this may be a repetition for some of you because many of you may already know prefix sums. But for anyone who is new to this, is it clear? So we can start with the next problem. Just to give one or two confirmations, please. Okay. So let's start with the next problem. So many of you said that you found this problem a bit difficult. Okay, so we will try to understand this. Let's see what happens. So the question is maximum and minimum sums of at most size k subsequences. Okay, so the question says that you are given an integer array nums and a positive integer k. Return the sum of the maximum and minimum elements of all subsequences of nums with at most k elements. A non-empty subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Since the answer may be very large, return it modulo 10 to the power 9 plus 7. Okay, fine. So the question is simple. Let me reiterate the question once. Okay. So the input is, so the input again is, as many questions have the same input, it is this array A1 till AN and an integer k. Okay. Now, what does the question says? The question says that you pick all subsequences of length at most k. Okay. So before that, let me just quickly explain what is a subsequence. So basically, if you have some array 1, 3, 5, 10, and 8, a subsequence is something which can be found by deleting some elements of this array. So suppose I delete this 3, this 10, and an 8. So what I get is 1 and 5. So that is what we call a subsequence. Similarly, 3, 10, 8, even that is a valid subsequence because we can delete 1 and 5 to get the subsequence 3, 10, and 8. Okay, so anyone new to this definition of subsequence? Yeah, exactly. So, okay, so when you mean, so a subsequence is nothing but a non-continuous subarray. So if you say that, but that would not be a valid term to say. So it is basically you take some subarray, but then you can take basically non-continuous values. You can skip things in between. So that is what a subarray is. Okay, that is what a subsequence is. I'm sorry. So now the question says that for some subarray, you pick all the subsequences of length at most k. So let us take this example, 1, 2, 3. So we have this subarray 1, 2, 3. Okay, just a second. Yeah. So the question says that you have this subarray 1, 2, 3. Now you look at all the subsequences of 1, 2, 3. So what are the subsequences of 1, 2, 3 which are possible? 1 is a valid subsequence. 2 is a valid subsequence. 3 is a valid subsequence. 1, 2, that's a valid subsequence. 2, 3, that's a valid subsequence. 1, 3, that's a valid subsequence. And 1, 2, 3. These are even this is a valid subsequence. And the value of k is given 2. So the question says, look at all the subsequences of this array which are of length less than equal to 2. So basically here, I do not consider this subsequence because this is of length 3, which is greater than k. So let me erase this. So I have erased this. Now the question says, for all these subsequences, find the sum of the minimum and the maximum values. That means look at the subsequence, check what is the minimum value of this. The minimum value is 1. And what is the maximum value? The maximum value is also 1. So you do a 1 plus 1. For 2, what is the minimum value? That's 2. What is the maximum value? That's again a 2. So do a 2 plus 2. For 3, do the same thing. It's a 3 plus 3. For 1 and 2, the minimum value is 1. The maximum value is 2. So it's 1 plus 2. For 2 and 3, the minimum value is 2. The maximum value is 3. So it's 2 plus 3. For this, the minimum value is 1. The maximum value is 3. So it's 1 plus 3. So you get all these terms, find the sum of everything and return it as the answer. So that is what the question says. If you look, they have very beautifully explained this test case. Okay. Yeah, here it is. So look, they have taken all these subsequences. They have taken the minimum and maximum as we did, found out the sum of all these, and then actually computed the sum of all this again to get the final total of 24. Okay. So everyone clear what the question expects for us? Everyone clear with the question? So no doubts with the problem statement, right? Okay. So now the first and the foremost most important part of this problem is looking at the constraints. Look what the constraints are. The nums.length is less than equal to 10 to the power 5 and k is less than equal to minimum of 100 comma nums.length. That means the value of k can never be greater than equal to 100. So these are hints you have to understand from the question itself. So constraints are usually a very good hint of a problem. So it says that n is less than equal to 10 to the power 5 and k is less than equal to 100. So that means that a big O of n square code would fail, right? A big O of n square code would fail. It will give a TLE because n is too large, 10 to the power 5 for it to pass. But a big O of nk code may pass. If you write a big O of nk code, that's 10 to the power 5 times 100. So that would be 10 to the power 7 and that may pass. So it may give an AC. So these are constraints which you have to actually look at times and then understand that, okay, what does the question setter expects us to us to do? Like, why are the constraints set like this? Okay. Okay. So now, first of all, what I will do is look at these two. The question is basically asking the sum of all these maximums and then the sum of all these minimums, and then you basically add them up, right? So why not solve the question one by one? So first of all, I will find the sum of all the maximums. Then I will try to find the sum of all the minimums, and then I will add them up. So I will do this 2 times. Okay, fine. So everyone clear what I'm trying to do? So basically, I will count all subsequences of length. I will take all subsequences of length at most k. I will first find the sum of their maximum elements. Then I will find the sum of their minimum elements. And then I will add them up instead of finding maximum and minimum at the same time. So fine with the idea? Okay, so Priyansh says that can we count the contribution of all the elements in the sequences? Yes, exactly, Priyansh. We will do something like that. So basically the problem here is that the number of subsequences can be huge, right? So suppose let me take some array 1, 4, 8, 2, 5, 6, 3, something like this. So now, and let us try to find the sum of minimum elements. So we are first computing minimum thing. So for all subsequences of length at most k, we will find the sum of minimums. Then again, we will do this same approach, exactly same idea to find the sum of maximums, and then we will add them up. So that is clear, right? So now let us try to understand how many times this 1 will appear. So any idea how many times this 1 will appear? So basically, what is the contribution of 1 to the answer? So basically, when you will write these sums, so basically look here. In this problem, look here. So in the problem statement, if you see 1, 2, 3, 1, 2, 3, and if you look at this minimum column, then 1 has appeared 3 times, 2 has appeared 2 times, 3 has appeared only once. So if you can find which element occurs how many times, then you can easily compute the sum, right? So instead of iterating over all subsequences and finding the minimum value, we will do a reverse technique. We will iterate over the elements and we will try to understand that, okay, how many times this element comes in this entire column. And then we will multiply that element with its frequency, do it for all elements, add them up, and we get the answer for the entire minimum, right? So any idea how many times? So suppose my k is given something. I'm not, so suppose k is something. So how many times or what will be the contribution of this 1 to the answer? Note that 1 is special here. 1 is the minimum element. So whatever subsequence you choose, 1 will always remain as the minimum. Okay, so let me ask a specific question. Instead of at most k and stuff, tell me, so this is the question, how many subsequences, how many subsequences of length 1, sorry, how many subsequences of length L have their minimum 1? Have their minimum equal to 1. So anyone? Okay, so someone asked to repeat the last point. So it is basically instead of, since the number of subsequences can be huge, right? So we will not enumerate the subsequences in any manner. We will enumerate the elements. So we will look at the elements one by one and then try to understand that, okay, so I will, so what will I do is, I will look at all these elements one by one. So I will look at one and then I will try to understand how many times one contributes to the answer. Then I will look at 2 and try to understand how many times 2 contributes to the answer. Then I will look at 3 and try to understand how many times 3 contributes to the answer. And this way I will go on. So my first question is, there are how many subsequences are there of length L which have 1 as their minimum? So anyone in the chats? Okay. So people are saying 2 to the power n minus 1. I'm not sure, but there is this L given, right? So I'm asking how many subsequences are there of length L which have their minimum 1. So now note this. If you want to make your minimum 1, then you have to pick this one. That is for sure. Because if you do not pick 1, how will you make the minimum 1? So 1 needs to be picked. And you need to keep the length of your subsequences L, right? So you have already picked one element 1. So that means for the remaining bunch of elements, you need to pick L minus 1 more elements. And note that picking any of them does not change the minimum because all of these are greater than 1 itself. So that means from these remaining n minus 1 elements, you need to actually pick L minus 1 of them. So the answer to this question is, how many subsequences of length L have their minimum 1? That is basically out of the remaining n minus 1 elements, choose L minus 1 of them. Isn't it? Anyone who is still confused? Okay, you're asking here L refers to K, right? No, actually, I am not, forget about K now. We will see how we will relate this K and L. So because it was given that the length is less than equal to K. So that means intuitively, you need to iterate over all possible length values from 1 till K, right? That is why this order Nk will come. So think about this. Why will this order Nk come? This K will come because you need to iterate over all possible length of subsequences from 1 to K. Because I know that the length of any length of a subsequence less than equal to K is allowed. So the value of L can be anywhere between 1 to K. So I'm asking the question for a general L, and then I will try to extend this for all L and then I will try to find the answer for all values less than equal to K by just making a loop. So is it clear? I asked how many subsequences of length L have their minimum equal to 1, that is n minus 1 CL minus 1. Yeah, exactly. If the length exceeds k, we will break the loop. Great. So Rakesh rightly said it's n minus one CL minus one. Okay, good. So finding the contribution of the minimum element is easy because you pick this element and then out of all these remaining elements, you actually need to, what do you need to pick? You need to basically pick L minus one of them out of n minus one. Great. So let us try to find the contribution of some other elements. So let me take that same array 1, 4, 8, 2, 5, 6, and 3. Okay, 5, 6, and 3. So now here it is where it becomes interesting. So suppose I change the question and I say that how many subsequences of length L have 2 as their minimum. So there are how many subsequences which have 2 as their minimum? Any idea? N minus 2 CL minus 1. Okay, Priyansh is right. But before that, someone said to again explain me how does this NCR part comes. So look what happens is that if you want to choose a subsequence, if you want to find how many subsequences are there of length L which have their minimum 1. So if you have to make the minimum 1, you have to pick one. You have no other choice. You have to pick one. That is one element for sure. Now, out of all these remaining elements, how many elements are there? N minus 1 elements are there, right? So N minus 1 elements are there. How many elements do you need to pick? If you want to make a subsequence of length L, you have already picked one element. So you have already picked one element. Remaining number of elements you need to pick is L minus 1. So how many subsequences are there? The number of ways you choose L minus 1 elements out of N minus 1, right? So that is how N minus 1 C L minus 1 comes from. Here the question was easy because whatever choice you make out of these n minus 1 elements, the minimum always remains 1. So this condition, have their minimum equal to 1, that always remains valid because 1 is the smallest element in the array. Okay, great. Now let's come to this second question. So basically we found the contribution of 1 in the answer. That was very easy. Now I am trying to find the contribution of 2 in the answer. Basically, I'm trying to find out how many elements are there, how many subsequences are there which have 2 as their minimum. So how many subsequences are there? So if you want 2 as their minimum, you have to pick a 2. You can't help with it. So this is something you need to always pick. There is one more thing. Since you have to keep your minimum 2, you cannot pick a 1. That is for sure. Because if you pick 1, then the minimum will be 1. It will not remain 2. So you can't pick a 1. So how many elements remain? So basically n minus 2 elements remain, right? So this is gone and this is gone. This is something which you have to always pick. This is something you will never pick. N minus 2 elements remain and you have to pick L minus 1 of them. So how many are there? It is n minus 2. That is the elements you have. Choose L minus 1 of them, isn't it? That is the number of subsequences which have their minimum as 2. Uh, is it clear? Anyone with any doubts? Okay, so Garv says that number of elements greater than 2, C Ln minus 1. Exactly, number of elements greater than 2, C L minus 1. And here the best part is that the number of elements greater than 2 is also n minus 2. So we can write n minus 2 CL minus 1, right? Now, so now, if you look at, if you try to find the contribution of other elements, the idea is very simple. So if you try to find out the contribution of this 3, so if you try to find out the contribution of this 3, so now again the same approach. You can't take this 1, you can't take this 2, you have to definitely pick this 3. So the n minus 3 choices remain. Out of these n minus 3 choices, you have to pick L minus 1 of them. So what is the value? N minus 3 CL minus 1. So don't you think? So what should be the answer? So basically you have some array. Suppose you have 1, 4, 2, 3, 5. Suppose you have this. I am trying to keep all the values of the array distinct for some time. Uh, Okay, so I'm trying to keep all these values of the array distinct for some time, and we will look what happens when duplicate elements are there. So now, we have 1, 2, 3, 4, and 5. We will try to find the contribution of all these elements in the answer. And suppose I have told you that I'm interested in subsequences of length L. Okay. So if I'm interested in subsequences of length L, so what is the contribution of 1? I said you the contribution of 1 is n minus 1 Cl minus 1. What is the contribution of 2? It is n minus 2 Cl minus 1. What is the contribution of 3? It is n minus 3 Cl minus 1. The contribution of 4, it is n minus 4 Cl minus 1. And what is the contribution of 5? It is n minus 5 Cl minus 1. Okay, now you may have problems saying that, okay, this value may n minus 3 may be less than L minus 1. In those cases, it will be just simply 0. We will take handle of it. We will handle that part in the code. But is the logic clear? Yeah, Sudhir, we will come to that part. Like what happens if the frequency of some elements is more than one. But when all the elements are distinct, then I think it's clear, right? Like the contribution part. Okay, great. So that means what do we need to do if all the elements are distinct? So if all the elements are distinct, it's simple, straightforward. You basically iterate over all these values of L. Okay. So now, as you all rightly mentioned, you all were saying it for so long that basically what you need to find the contribution of this in the sum, right? So it will be simply n minus 1 Cl minus 1 into 1. This will be n minus 2 Cl minus 1 into 2. So that is basically the contribution in the sum. Basically in the sum, there are these many 2's. So what is the sum of this entire thing? It is its frequency into 2, right? And how will you do this? How will you do this? You can simply sort this array. So you just simply sort this array. So the idea is you sort this array. So after you sort this array, you get a sorted array 1, 2, 3, 4, 5. What do? You just simply say that, okay, I will run a loop for I equal to 0 to n minus 1. And I also don't know the length. So I will also run the length part. So L equal to say 0 to k. And now I will just add sum plus equal to. So what do we add? Like if I is 0, then we had n minus 1 here. So it is something like sum plus equal to n minus I minus 1 C L minus 1 into this value. So if the array is nums, into nums I. So the code should look something like this. Everyone agrees? Okay, how did I reduce n in NCR? So basically, see what happens is, suppose I've sorted this array. So I've sorted this array. How many subsequences are there where you have 1 as the minimum? So it is basically, you have these many elements and you have to choose L minus 1 of them, right? So it should be n minus 1 Cl minus 1. Now, how many elements are there which have 2 as the minimum? If you want to keep 2 as the minimum, these are the elements which you can choose from. So there is one less choice. So it should be n minus 2 Cl minus 1. Similarly, if you want to keep 3 as the minimum, if you keep 3 as the minimum, then you cannot choose elements from the left, right? As it will change the minimum itself. So if you want to keep 3 as the minimum, you have to choose 1, 3. And remaining all these values, you have to choose from here. So note that whenever the value of I is increasing, the number of choices here is decreasing by 1. And this is remaining L itself. So it's clear, right? So it will be n minus 3 for 3, exactly. L equal to 0. Yeah, L equal to 0 has no meaning, exactly. So sorry for this and thank you for pointing out. Okay. Yeah, so if I have L equal to 0, so it has no meaning. So I start from L equal to 1. So I hope that it's clear. So as soon as as long as the elements are distinct, they do not create any problem, right? Okay. Now, what is interesting is that this same approach also works when elements are not distinct. So for example, I have this array. I have 1, I have 2, I have 2, I have 4, I have 5. Now note that when you are counting subsequences, when you are counting the number of subsequences, individual identity of an element matters. What do I mean by that? I mean that, okay, these are the same 2's, but these 2's were in different indices in the array, right? So this was maybe at some index 3. This was maybe at some index 5. Okay. So think about it like this. When you are counting the contribution of this, you basically contribute, you basically count that, okay, how many subsequences are there which have their leftmost minimum as 2. So if you want to keep the leftmost minimum as 2, you can pick elements from here. So it should be n minus 2 CL minus 1. Now, if you want to find the contribution of this 2, so the position of this 2 is already 5. And if you want to keep this as the leftmost minimum of the subsequence, then the only choice you have is these remaining elements. So basically, in the questions of subsequences where every element has an individual choice, I mean, like has an individual entity, then it is basically very same as handling distinct elements only. Like the number of choices do not change. And that is the reason the exact same algorithm which we discussed when there were distinct elements remains same here. So everyone agrees what happens? So won't it be n minus 3 when we take the second 2? Exactly, it will be n minus 3 when we take the second 2. Because note what happens is, so basically you have this array 1, 2, 2, 4, 5. So I have this array. So let's suppose I have this array 1, 2, 2, 4, 5. Let me just a second. Okay, so suppose this is my 1, 2, 2, 4, 5, and the value of k is 2. Okay, so the value of k is 2. So what are the subsequences which I will consider? I will consider a 1, I will consider a 2, I will consider a 2, a 4, a 5. Okay, let me reduce the size of the array by 1. It's becoming very long. Okay, so I do not have a 5. So it's 1, 2, 2, 4. Then I have a 1, 2. Then I have a 1, 2 again. Then I have a 2, 2. Then I have a 2, 4. And then I have a 2, 4 again. Right? So now look, so this is the leftmost 2. So there are two 2's. If you look at very carefully, there are two 2's. Let me call this 2, 1 and let me call this 2, 2. So basically this was 2, 1. This was 2, 2. This was 2, 1. This was 2, 2. This was 2, 1. This was 2, 2. So this was 2, 1 and this was 2, 2, right? So what is the contribution of 2, 1 in the answer? So as per my logic, that the contribution of, so here there is a contribution of 2, 1. 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 And it's done, right? Now, what is the contribution of 2, 2 in the minimum? If I don't, note that here also I need to take n minus 3 only. I can't choose this 2, 1. Because if I would have taken n minus 2 here and n minus 2 here, then that means, then cases like this, where there is a 2, 1, 2, 2 comes, I take a contribution for 2, 1. I also take a contribution for 2, 2. So that will be overcounting. So here, so when I have this array, so basically what is the contribution of, and I need to find the contribution of all elements. I know the contribution of this 1 is n minus 1 CL minus 1. The contribution of this 2 is n minus 2 CL minus 1. Luckily, the contribution of this 2, as in the case of distinct elements, should be n minus 3 CL minus 1 only. Why? Because if you take it just like for this 2, you took n minus 2 CL minus 1. If you also take for this 2 also n minus 2 CL minus 1, that will create problems, because in cases where 1 and 2 both appears, you will be overcounting the value of 1 and 2. So that is the reason when you are trying to find out the contribution of this second 2, you can never pick this first 2. Because if you try to pick this first 2, then you are basically overcounting. The contribution of this first 2, because there were subsequences where 1 and 2 both were there, you have taken the contribution of both these 2's in those cases. So that is the reason this behaves exactly same as distinct elements. Uh, Anyone with any doubts? Yeah, we treat them individually, exactly. Okay, so Rakesh says that it is failing on some test case. It would not. Like I've given the contest. Just hold on for a minute. I will show you the code. Okay, great then. So this is how you find the contribution of the minimum elements. By the exactly the same manner, you can find the contribution of maximum elements. So how will you find the contribution of maximum elements? Just do a simple thing. Run this same algorithm. Just reverse the array first. So reverse the array, make it 4 2 2 1, and then just again add up the contributions. For this, what should be the contribution? It should be n minus 1 CL minus 1. For this, the contribution should be n minus 2 CL minus 1, and so on. Okay, so exact same logic. You once find the minimum, the sum of the minimums, you find the sum of the maximums, and then you finally add them up. So let me quickly show you the code once, and then we can discuss if we have any more doubts. Okay, so this is the code. Q is the value of my mod. M is 109. You can keep it anything greater than 100. It's all right. And the value of N is something greater than 105. So this works. Add is just to add two numbers given the modulo. So this is something like modular addition, and PDT is modular product. So that's all right. This is something which I'm not explaining now. This is just finding the combination array. So finding the value of say NCR, you can just you can just make an array where with this C array where CNR stores the value of NCR. There are very simple recursive ways of adding it up and doing it. And there are many ways to do this. You can easily find this. So here is what the code is. So I've sorted this nums array. This answer is the variable where I will actually store the answer. And this m is n minus 1. So initially I have m choices. There are n minus 1 choices, and this value of m will keep on decreasing. So now look what I have done. I have stored the value of numSci in S, so I think that's all right. And then for all the values of j, such that j is less than k. So this is basically I'm iterating over all the possible values of length. So like the value of L can go from anything from 1 to k, right? So that is what I do. So L can go anything from 1 to k, and L also has to be less than equal to m because that is the number of choices I have. Basically, if L becomes greater than m, the value becomes 0. So I don't do that. And then I find the value of P. So that is basically the entire sum. And then I multiply P with the contribution with the value of this element. So adding it the frequency with the element to get the entire contribution. And then I decrease the value of M from n minus 1, it will keep on decreasing to n minus 2 and so on. So this is how it works. I run the same code by reversing once to find the maximum element, and then I finally print the answer. Okay. So is it clear for everyone? Anyone with doubts? Could not get something or so on. Okay, fine. So if you all do not have any doubts, then we will move to the next problem. Okay, great. So let's move to the next problem. I hope this question is clear. So this was the third question. It says that you are given an even integer n representing the number of houses arranged in a straight line and a 2D array cost of size n into 3, where cost ij represents the cost of painting house I with color j plus 1. Okay. So the houses will look beautiful if they satisfy the following conditions. No two adjacent houses are painted the same color. Houses equidistant from the ends of the row are not painted the same color. For example, if n equal to 6, houses at position 0, 5, 1, 4, 2, 3 are considered equidistant. And the question says that return the minimum cost to paint the houses such that they look beautiful. So let me quickly explain the problem once. Okay. So the input is simple. Input is simple. It is n. So n, which is guaranteed to be an even integer. And then there is some cost array which is given to us. So this cost array tells us that, okay, you have this ith house. You have this ayat house. What is the cost to actually paint this ayat house with color J? So this is some information which this cost array gives us. Now we have basically n houses. So there are n houses. So 1, 2, 3, and it goes till n houses. Okay, so there are n houses. And you have to color every house with some color. So basically I have to, and then there are only three possible colors given. So there are three colors, 1, 2, 3. You have to color every house with some color. So suppose I give 5 here. Oh, sorry, we had just three colors, right? So let me give 2 here, 1 here, 2 here, 2 here, 3 here, 1 here, 2 here. So this is some coloring of the houses. So this is some way you can color a house. Now the question says something new. The question says that we will call something beautiful if two conditions are satisfied. We will call something beautiful if two conditions are satisfied. Number one, two adjacent houses, two adjacent houses must have different colors. Two adjacent houses have different colors. So basically, this explanation which I showed you just now, this coloring is not a beautiful coloring because then you have two houses with the same color. So this should not happen. So two houses must have different colors. This is first one. The second one is houses equidistant from the left to the right must have different colors. That means like this. So suppose this is some house. So this is some array. So we have here the value of n is 8. It basically means that suppose take index 0 and index 7. Take index 0 and index 7. They must have different colors. So 0 and 7, they must have different colors. Basically, one is at 0 distance from the left, one is at 0 distance from the right. They must have different colors. Similarly, 1 and 6. So basically, it is something like a pair. So like 0 and 7, they must be of different colors. 1 and 6, they must be of different colors. 2 and 5, they must be of different colors. And 3 and 4 must be of different colors. So any two houses which are connected by an edge in this diagram must have different colors. Apart from that, adjacent houses also must have different colors. So these are some constraints which needs to be satisfied. There is a cost array given, and the question asks that, okay, what is the minimum cost to paint all these houses such that it remains beautiful? Okay. So just to confirm once whether you all have understood or not, can someone quickly tell me that, okay, is this coloring beautiful? And suppose I have this, and suppose I have this. Are these three colorings beautiful? Anyone? Okay, Priyansh asks how to find that there are 1, 2, 3 colors only. I think there was no suspense here. Yeah, they gave us a cost ij, a 2D array cost of size n cross 3. So they are giving a size an array of size n cross 3, and the values of so basically we cannot have the values of j greater than 3, right? There are only three possible values, 1, 2, 3, because the size of the array is something like that. If there were 4 colors, they would have given us an array of size n cross 4, isn't it? Yeah, so exactly. The first one is a valid coloring. This is a valid coloring because all conditions are satisfied. This is not a valid coloring because two houses have adjacent colors, so this is not valid. This is not beautiful, as they say. And this is also not beautiful, as because we have this pair, which does not have different colors, which should have different colors as they're equidistant from the left and the right. So everyone clear with the problem statement? Anyone, any confusions in the problem? Everyone clear what does the question says? Okay, you tried something without memorization, it was giving TLE. With memorization, it was giving wrong answer. Okay, we will look into it. But is the problem statement clear? Anyone, any doubts on the problem statement itself? No, na? Okay, great. Uh, so now let us try to understand what happens. So it is something like this. First of all, I think from experience, like you should have actually seen that whenever you have to color some an array of in houses where there are some colors which are allowed and some colors which are not. Or maybe I think you have seen questions like how many ways you can color an array such that any two adjacent indices have different colors. Then in almost all of these questions, the pattern is very similar. The pattern is something like, okay, that pattern, the usually in all these problems, the pattern is something like, okay, maintain some DP state. So maintain some DP state, say I comma j, where say which basically says that okay, how many ways you can color the first I positions such that the last color is j. Like this is a very common dynamic programming state because the no, remembering the last color helps us to actually write the transitions. As we know that okay, if the last color is J, then the previous color cannot be J. So it has to be something different from J. So these are information which are important. So anyone, so are you all like, have you ever seen these type of questions like where you have to make a DP state like this? Or was it completely new? Okay, yeah. So there are many, there are many questions. Okay, so Rakesh suggests that bank robberies. Yeah, exactly. Kind of frog jump. There are many, many types of dynamic programming questions almost on all platforms where you will find the pattern is very similar. That, okay, you have to color an entire array using some, and there are some rules given. Then, okay, what do? You maintain some DP, a 2D DP, DPIJ, which stores that, okay, how many ways you can color the first I indices such that the last color is J. That's fine, right? But in this problem, there is something new. The problem is, if I try to maintain this type of state, that okay, if I try to maintain this type of state, dp I comma j, that okay, how many ways you can color, how many ways I can color the first I indices. So how many ways I can color the first I indices such that the last color is j. The problem with this dp state is actually in the question itself. The question has many constraints which actually correlate or relate this last part of the array with this front part of the array, this prefix of the array with the suffix as well. Like there are conditions that okay, this if this distance is also I, then what does it says that okay, if this is j and the color of this is k, then j has to be something not equal to k, right? So this is one constraint which you need to follow. So instead of maintaining a DP state which only stores the prefix length, why don't we say, why don't we maintain some state of this form? DP I, where I maintains the length of both the prefix and the suffix, because we understand from the structure of the problem that, okay, both the prefix and the suffix needs to be actually handled during the writing the transitions. So let me say that, okay, DPI is basically the number of ways you can color the prefix and suffix both of length I. So if you now, if you store prefix and suffix both of length I, you also need to store their colors, right? So the color of the, suppose the color of the prefix ending is J and the color of the suffix ending is K. So instead of storing one colors, which you used to store in many DP problems, now you have to actually store two more colors, DPIJK. So let me formally write what does DPIJK maintain. So DPIJK is nothing but something like, sorry. So DPIJK is minimum cost, minimum cost to color both prefix and suffix, both prefix and suffix of length I, of length I, such that the prefix ends with J, such that prefix ends with color J and suffix ends with color K. and suffix ends with k. This is what our DP state is. Anyone confused with the DP state? Okay. So Ishan says to repeat once. So see, this is something. What DP state should you actually pick comes from a bit of experience. So if you have actually looked at problems like this, where you need to count or where you need to find the minimum cost of some coloring which holds some conditions, then you would have seen that okay, we need to count. We have seen must have seen states like DPIJ, right? But here, since the question itself mentions that okay, that the prefix that when you actually color this prefix part, so when you actually color this prefix part, there are also conditions which are enforced in the suffix part of length I as well. In the questions where you actually something like a bank robbery or something, where you actually write DPIJ, in enforcing any conditions in the prefix keeps the suffix independent, right? So that is the reason keeping these type of states was all right. But here, since the states are related, I make this state DPIJK. Clearly understand what does DPIJK represent. DPIJK says, so what does DPIJK store? So DPIJK stores what is the minimum cost. So suppose you have this entire array. So you have this entire array, and suppose these are the initial I indices, and these are the later I indices. These are the first I indices, these are the later I indices. DPIJK stores that okay, you have to color this last box of this index ij. You have to color last box of this index ik, and what is the minimum cost to color everything? So what is the minimum cost to color this prefix of length I? What is the minimum cost to prefix the cost this suffix of length I, both of them together, such that the last cell here is j and the last cell here is k. So that is what our DPIJK stores. Is it clear? The definition of the DP state. Uh, okay, good. So now, if the definition of the DP state is clear, so now let us try to write the base case and the transitions. Okay. So first of all, let's write the base case. Can anyone tell me what should be the base case? Okay, let's handle things one by one. So the first thing is what happens when j is k? What happens when j is k? Anyone? What if j is k? So j is equal to k. Then what is the minimum cost you require? Correct. So if j is k, then that actually invalidates the condition of the problem. Because if the value of j is equal to the value of k, then that basically means that the color of this cell is equal to the color of that cell. But these cells are already matched, right? They're equidistant from the left and the right. The question statement itself mentions that they has to be of different colors. So this is not possible. So when you are not possible and you have to find the minimum cost, the best thing is you write DPIJK as infinity. So it is something like that. It takes infinite cost to actually do this. You can never do this. So if j is equal to k, then DPIJK is infinity. That's clear. Let's write, okay, what should happen if I is 0? I is 0 and j is not equal to k, for example. Now, all cases where we will assume is j is not equal to k. Then what happens when I is 0? That is the base case. Can anyone quickly say me what is the value of DP0JK? One. Okay. So when I say that DP0JK, that means I basically need to fill this cell, the first cell with a color J, and I have to fill this cell with the color K. Nothing else, right? So what should be what should be the cost of doing this? So what should be DPIJK? Sorry, what should be the value of DP0JK? It's a simple base case. So what should be DP0JK? I just need to fill the first cell with a color J and the last cell with a color K. Min plus max could not get it, but the value of dp0jk, don't you think it should be simply that, okay, you have to fill the first cell with color J, so it should be cost 0j, like the cost array is given, right? Plus you need to fill the last cell, so it should be cost n minus 1k, isn't it? Fill the first cell with a color J, fill the last cell with a color K. So that should be the value of dp0jk, right? Is it clear? Okay, fine. So the base cases are clear. We are sorted with I equal to 0. We are sorted with the case j equal to k. And now we need to write the transitions. So somehow we need to write the transitions. So here it is. So whenever you are trying to write transitions in these questions, I think you have also seen in other questions as well. So I need to write the transitions. So suppose this is the ith index. This is the I minus 1th index. Similarly, if this is I and this length is entire I, so it should be n minus I minus 1, I guess. And this should be something n minus I, something like that. And I need to find the value of dpijk, right? So what is the value of dpijk? You need to color this cell with j. You need to color this cell with k, and so on. And what is the minimum cost to cover them? So now, since you have to color this with j and you have to color this with k, then what should be the minimum? So first of all, there are two parts which will always come. So you have to take cost. So basically cost ij, that is basically the cost to fill this ith cell with a color of j, plus a cost of n minus I minus 1k. So that is basically you have to fill this cell n minus I minus 1 with a color of k, sorry. So it should be n minus I minus 1 comma k. So the job for these two cells is done. You have colored this cell, you have to color this cell. You have to color this entire thing, to color this entire part. So what should I write apart from this in the transitions? What should be the transitions then? Anyone? Okay. So basically this value, like what is the minimum cost to store this prefix and the suffix, these are already stored in dp states, right? So basically what do I need to do? I don't know what color this had. I don't know what color this had. So suppose this had a color of nj and suppose this had a color of nk. So let me take minimum over all values of nj and nk. So minimum of over all values of nj and nk, dp I minus 1 nj nk, right? So basically what is the cost to color this prefix of length I and this prefix of length I? That is basically color these cells first. So that is basically which you have already done. And then color the remaining part, which you have already computed in the DP. So just use the transitions, isn't it? So this should be the case. But here you will not take all values of nj and nk. Why will we not take all the values of nj and nk? Because we need to ensure that the coloring is beautiful, right? So we will only take those values where few conditions are satisfied. So what conditions do you think needs to be satisfied? Anyone? What conditions should nj and nk satisfied in order to be a valid coloring, in order to be a beautiful coloring? Not same to adjacent, correct. So it should not be same to adjacent. So that means the conditions which should be satisfied, first one is uh, nj should not be equal to j. For the simple reason that if nj becomes equal to j, then these two will be adjacent. So that is something which we do not want. The second condition is nk should not be equal to k. Because if nk is equal to k, Then what is the problem? The problem is these two will become adjacent. So is it clear? J is not equal to Nj, K is not equal to Nk. Exactly. So these are the two conditions. Apart from that, you can write one more condition, or you may even skip it, and that is that Nj is not equal to Nk. Because even these two cells are equidistant from the left and the right, right? So even these two colors have to be something different. It should not be Nj and Nk. So Nj should not be equal to Nk. So you can handle it directly here. Or even if you do not handle this, it would be taken care of because the value of dp Nj Nk, because of our base case, would have been already stored infinity. So it would never come up in this minimum. So it will not create a problem. So are the dp transitions clear? Exactly. They are filled before must be different. So everyone, is it clear? Okay, so Rakesh says yes. Other guys, like, has everyone slept? Okay, I think I have to assume that it's clear. So let me show you the code once. So probably that will give you an idea. So here is the code. You can actually memorize it. You can write an iterative solution. That actually it's already up to you. I have shown you a basic case where I have tried to write the recursion. So this is the recursive state. Now you can implement this recursion as memoization, or you can write an iterative solution, as long as it's completely up to you, and all of these are fine. So this code may look a bit messier, but the idea is very simple. So basically, this is what I store the values of dp0. So this is simply if I is not equal to j, then I know that dp0 ij is cost 0 I plus cost n minus 1 j. If I is equal to j, then dp0 ij would have to be infinity. Now I do this for same thing for ijk. If j is equal to k, then dpijk is infinity, right? And if j is not equal to k, then I take the minimum of all these values, where I take all these conditions that nj is not equal to j, nk is not equal to k, and nj is not equal to nk. And finally, I add up the cost of coloring the last cells, the ith cells, cost ij and cost n minus I minus 1 k. Okay. So can anyone tell me, okay, so these DP values are populated. So it's perfectly fine up to this. But where is the answer stored? So after the DP array is populated, where is the answer stored? Anyone? So suppose I've done this entire for loop, or you have done the memoization and everything. So what value do we return as the answer? DP n by 2, DP n plus 1 by 2, but DP is actually a 3D state, right? Like it stores an index I, and then it stores two colors J and K. So what will you return? So basically you return as answer is this. So if you need to return as answer, then basically what do you need? You need to find the minimum cost to fill the entire array, right? So if I take zero based indexing, so this is 0, this is n minus 1. Here are the two mid positions. This is n by 2 minus 1, and this is n by 2, right? So I need to fill this entire, so I need to fill this entire prefix up to length I, and I have to also fill this entire prefix here. So that means the answer should be the answer should be dp n by 2 minus 1 jk. So what does dp n by 2 minus 1 jk stores? That basically stores how many ways we can fill the entire array. So this color is j and this color is k. So just take the minimum over all these values. Take the minimum over all these values j and k, isn't it? So whatever minimum you get, that is the answer. So that is what I've done. So I have iterated over all these values of I to j, and I have taken the minimum over dp n by 2 minus 1 I and j, and finally I've returned the answer. Okay. So this was what the code is. Okay. So anyone with any doubts, you can please write. Otherwise, we will try moving to the next question. Okay, great. So since you all have do not have any doubts on this problem, yeah, Ishant, you said yeah, okay, you can share your approach, but let's let it keep it quick because already it's a lot of time. Probably 1.5 hours, half hours is over, and we have one more question to discuss. Okay.
Hello.
Yeah, Ishant.
Yeah, so basically what I did, I maintained a previous variable and I maintained an array to store all the colors so that I can calculate whether the indices are equidistant or not. Like suppose I am at some index I, right? So I will check
Okay.
that whether it has some equidistant index on which I can't move.
Okay.
Yeah. So this way I tried, but like memoization failed, although the recursive code worked. It was giving TLE.
Uh, the recursive code was giving TLE, so that basically, but your memorization code gave a wrong answer, right?
Yeah, right. I think I have
See,
memoized it wrong way. So might be.
okay, you can then I think probably share it with the mentors. They can look at your code and understand. But then if you say that your recursive code works,
Yeah,
but since your recursive code gave TLE, that
yeah.
does not at all mean that it would have given right answer if it would have got enough time. So maybe your memorization code is
Mhm.
failing for larger test cases, and probably the recursive code would have also failed for those test cases, but it did not even completely executed in that time itself, isn't it?
Okay,
So
okay,
it may happen that your memoization is wrong, but it may also happen that your logic is itself wrong.
got it.
Okay, so you can share it with the mentors and probably they will help.
So
Okay, so let's start with the next question then. So this was the fourth question of the contest. The question is simple, but then I will ask you all to keep a bit of your attention here because it was not very trivial and it had some ideas which would be helpful if you know those ideas beforehand. Like there were small ideas to solve this problem. Okay, so the question says that you are given an integer array nums and a positive integer k. Return the sum of the maximum and the minimum elements of all subarrays with at most k elements. A subarray is a contiguous non-empty sequence of elements within an array. So basically, this is the exact same version of question B, but in question B, we were allowed to take subsequences. Here, we need to actually choose only subarrays. So that means they have to be contiguous. If you see this example, the nums array is 1, 2, 3, and the value of k is 2. So they pick up all those subarrays which are of length less than equal to 2, calculate their minimum, calculate their maximum, and finally return the sum. Okay. So so the question is again the same. So the input is so the input is some array a1, a2, and it goes till an. You need to iterate over all subarrays L to R of size less than equal to k, of size less than equal to k. You will find its minimum value, you will find its maximum value, take its minimum, take its maximum, add them up, and sum it over all possible subarrays and return it as the answer. And return it as the answer. So is the question clear? Everyone understood, right? Okay, great. So since the question is clear, first of all, what I will suggest is forget about the question. Just completely forget about the question and I will try to explain one more question or probably something which will come very handy or very useful in many problems. So this is an idea which you should know of as theory maybe or maybe as a prerequisite, and you can use the same idea in many problems. So forget about the question now and look at this new question. So the question is that suppose I give you an array. I give you an array 3, 2, 4, 8, 6. Then in order n time, you have to tell for all these elements what is the next greater element. So that means, suppose you have 3, 2, 4, 8, 6. What are their indices? Their indices are 0, 1, 2, 3, and 4, right? So now you have to make two arrays, one array R and one array L. In the R array, you have to tell me, that, okay, what is the nearest index greater than that index I, which is greater than it. So like for this index, what is the nearest element greater than it? It's 4, right? So you store its index here. So you store 2 here. For 2, what is the nearest element greater to it? It's 4, right? So store its index here. Store 2 here. For 4, what is the nearest index greater to it? It's 8, right? So you have to store 3 here. For 8, what is the nearest element greater to it? There are no greater elements from 0 to 4. So store some invalid index. Let's store 5 here. So 5 is something here. It's outside. And for 6, again, there are no elements greater to it in the right side. So store a 5 here. Okay. So this is how this array is created. For the L array, simple, again, same logic. So basically store the nearest element which is greater than it to its left side. So for 3, what is the nearest element greater to it in the left side? Suppose it's -1. This index is -1, so store a -1 here. For 2, what is the nearest element greater to it in the left side? It's 3, right? So store a 3 here. So basically store a 0 here, the index of that element. For 4, the nearest element greater to it, there are no greater elements, so store -1. For 8, again, there are no greater elements, store -1. For 6, again, okay, there is this one greater element, 3, so store a 3 here. So you need to pre-compute these two arrays L and R. This is something given in the question. So is the question clear? This is a new question. Okay, yeah, exactly. We can use a stack to do this. So if you can actually look at this GFG block. So it says that next greater element for every element in given array. It very beautifully explains the approach of how can you use a monotonic stack to create or populate these two values L and R. This is This is very useful in many problems, and you will actually use it many times. Okay. So probably we will not get enough time to explain this approach, as it uses a monotonic stack, and making a dry run would take a lot of time. But if you try to understand this explanation, then you can actually, this idea would be used as a prerequisite. Okay. Okay, so let's begin. So how many of you are like already know this approach? Anyone who does not know this approach out of you all? Okay, good. So if you know this approach, then the explanation which follows would be a bit easier for you to understand. So I think it's good that almost all of you know this. Yeah, so it's fine. Uh, so now what do we do? What do we actually need to do is we need to check that, okay, we will use the same approach as the previous one, something which we did in question number B. We will try to find the contribution of every element in the answer. So suppose I have this array, 3, 2, 1, 8, 4, 6. Okay. And again, we will follow the same approach. We will find the answer for minimums. We will find the answer for maximums. We will add up the contributions, and then we will finally add both of them to get the answer. So this is exactly something which we did in problem B. So something here, for all these subarrays, instead of iterating over all subarrays, because the number of subarrays is large, it's order n square, we will try to pick all elements and find their contribution in the minimum column. We will try to find their contribution in the maximum column. Then we will finally find the sum, and then we will add them up. Okay. So is the basic idea clear? Like what we are trying to do, something exactly which we did in question number B. Okay, fine. So how will we do this? So for the next part of the problem, I just assume that the L and the R arrays are completely computed for me. So I will not care about those L and the R values. So suppose I am choosing this Mn. So I will try to find out the contribution of the minimum elements. Okay. So I will try to find the contribution of these minimum elements. So for 8, so suppose for I have this 8 and I want to find out, okay, let us take some more interesting element. So let me take, okay, just let me insert a 4 in between. Let's forget about this and take something like this. 3, 2, 7, 5, 4, 2, 3, 8. Okay. Now suppose I want to find the contribution. We are trying to find out the maximum array's contribution. Okay. So for this 4, we have stored in the array Li and Ri what is the nearest element closer to it, which are larger than this. So here where is the L array points out. For we are now suppose trying to find out the contribution of 4. We will try to find out the contribution of every element like this. So here is where L points and here is where R points, right? The nearest elements which are larger than this. Now you have to think about this. Now you have to think about this that, okay, I need to find out all those subarrays where 4 is my maximum element, right? So I need to find out all those subarrays of length less than equal to k where 4 is my maximum element. So if 4 needs to be the maximum element, it has to be always inside this region L to R, isn't it? It can never exceed L or R. So because if you pick any subarray which has 4 and something like this, then 4 will not become the maximum because there is a larger element already present here. Similarly, if you take this subarray, then 4 will not become the maximum because there is a larger element always present here. So that means, so what does that mean? That if you have some index I, so suppose you have this some index I, and here Li appears and here Ri appears. We need to only compute those subarrays. We need to pick only those subarrays which include I and which are inside this range Li to Ri. In only those subarrays, I is the maximum element. So we will get a contribution of I. Is that clear? So basically, we need to count the number of subarrays for some index I in the range Li to Ri only. Okay, Ishant. So Ishant, what are we trying to do? We are basically trying to find the contribution of every element, right? So basically, I am trying to find out, okay, how many subarrays are there which have 4 as the maximum, right? So we will try to find out how many subarrays are there which have 4 as the maximum and then multiply it with 4. That is the contribution to the answer. Now I am saying that if you try to find out how many subarrays are there which are 4 in the maximum, which have 4 as the maximum, then you can never pick a subarray of this form which includes Li. Because if you include Li, then the value at Li is obviously greater than the value at I, right? That is what the definition of Li is. That is how we have used the stack to create the L array. So since the value of Li is greater than the value of I, we can never pick a subarray which includes L. Similarly, we can never pick a subarray which includes R. So what I'm saying is that if I have some index I, so if I have some index I, and then there are two pointers, one at Li and one at Ri, and if I need to consider those subarrays which have I as the maximum, I need to pick only those subarrays which lie in this range Li to Ri. I can never exceed that. So Ishant, is it clear? Okay, great. So I know I am in this region Li to Ri somewhere, and I need to find out the number of number of subarrays of size less than equal to k, which includes I. So that is my idea. Okay. So now let me also show you the code side by side, so we understand what are we trying to do along with this. So if you look here, if you look, okay. So basically, if you look, I have n is my nums dot size, that is the size of the array. Answer is 0. And then we have two basically local scopes here, no, where we will try to compute the maximum and the minimum contribution. And then we will add up answer and then we will finally return. So these two codes are exactly same, like exactly same. Just what differs is that here while creating the monotonic stack, I've used the greater than equal to symbol, and here I've used the less than equal to symbol. So one time we are trying the contribution of these minimums, and other way we are trying to find out the contribution of these maximums. Later we will add them up and find the sum. Okay, so these are repetitive parts of code. So I just need to understand this part. So this part is something which you can understand from the GFG blog, or many of you already know it, right? So this is something where I just populate these L and R arrays. So these L and R arrays, I use a monotonic stack and something and a simple loop, so that in order n time I can pre-compute the L and the R values. Okay. So now this is the part which is interesting. What I'm trying to do here is I know these values Li and Ri, and I will try to find out the contribution, or how many subarrays are there of length less than equal to k, of length less than equal to k, which include I, because I know those are maximum, right? So look at the first two lines. First two lines says that LD is I minus Li and RD is Ri minus I. What do I mean by this? Okay, no. First of all, let us look at these lines. Li is max of Li comma I minus k, and Ri is min of Ri comma I plus k. Why do I do that? I simply say that, okay, I need to count only those subarrays of length less than k, right? So suppose I have an index I here. So I have an index I here, and suppose here is where my Li. Sorry, here it is my Ri, and suppose here it is Li. So just a second. So here I have an Ri, and here I have an Li, right? Now I'm saying is that, okay, I need to count only those subarrays which have length less than equal to k. So if Li is much less, then it is of no benefit. Just push this Li and make it stand at I minus k. Similarly, push this Ri and make it stand at I plus k. If Li is greater than I minus k, Li will be somewhere here and it will not create any problems. But if Li is very far away, then there is no point keeping Li very far away, because we can never take subarrays of length greater than k, right? And those subarrays must include this in the position I. So that is the reason we say that, okay, let me do what I am doing. Li is max of Li comma I minus k, and Ri is minimum of Ri comma I plus k. So is it clear why I did that? Okay, so that part is clear. Now what I do, LD is I minus Li, RD is Ri minus I, MND is minimum of them, MXD is maximum of them. Okay, what is that? So too many terms, but very easy. Like what do I do? I say that, okay, after I have shifted this, let me call this LD. So this is the left difference. And let me call this RD. So this is the right difference. Fine. And what do I say? I say that, okay, let MND be the minimum of them. So MND is nothing but minimum of LD and RD. And MXD is maximum of LD and RD. Okay. So now follow me a bit, because from here there are just 2-line observations, but these observations are very crucial for the problem. Okay. So suppose I have this index I. I know that this part may be a bit tricky, and this is where the question many people would have stuck. So suppose this is Li, this is Ri. So this is LD, and this is RD. Can someone tell me how many subarrays I can form of length 1? How many subarrays of length 1? Anyone? How many subarrays of length 1 which LD plus RD plus 1, is it? Like, how many subarrays of length 1 which includes I, right? So this is important condition. We are trying to find the contribution of I. So we are trying to find out this contribution of this I. So whenever you pick some subarray, it must be in this range Li to Ri. That is okay. But it should also include the index I. That is also important. So how many subarrays of length 1 which includes I? Exactly 1. So how many subarrays of length 1? It's 1, right? Similarly, how many subarrays of length 2? I assume that k is larger than 2. So how many subarrays of length 2? Exactly 2. So that means the number of subarrays of length 1 is simply 1. The number of subarrays of length 2 is simply 2. The number of subarrays of length 3 is simply 3. The problem will appear when does the problem appears? So suppose LD is less than RD. Okay, suppose LD is less than RD. So my MND is basically LD and MXD is basically RD. Suppose this. So how many subarrays of length MND plus 1? That is interesting. When we are considering lengths which are smaller than both LD and RD. So when we are considering lengths, suppose which are less than equal to MD. So I know. So think about like this. So how many subarrays of length 1? So how many subarrays of length 1? Only one subarray. How many subarrays of length 2? Only two subarrays. How many subarray of length 3? Only three subarray. How many subarrays of length MND? How many subarrays of length MND? MND subarrays. So is this part clear that up to MND, it will just be an increasing order? Is it clear? Okay. So up to MND, we do not have any problem. So the number of subarrays would be simply increasing order. And what is the sum of all this? Sum of the number of subarrays, that is 1 plus 2 plus 3 plus dot dot plus MND, which is simply MND times MND plus 1 by 2. Fine, right? So if you look at my code, so this is where the next line comes. Answer plus equal to MND into MND plus 1 by 2 into num psi. So that is basically, this is the number of subarrays which are of length less than equal to the minimum distance. And then I multiply it with its value to get the contribution. So up to this, it's fine, right? So up to this, it's fine. Okay. Now let us come. So how many subarrays are there of length MND plus 1? Let me show you using an example. So suppose I have an I here. So suppose I have an I here. So this is this I. And suppose there are 3 more indices here. And suppose there are 5 more indices here. So basically MND, if you look at it, it's 4. Right? So basically MND is how many cells here? So it's 4. And MXD is how many cells here? So it's 6. So MXD is 6. And suppose K is something larger, say K is 8. Okay. So I already, we have seen that how many subarrays of length 1? There is only one subarray of length 1. How many subarrays of length 2? There are two subarrays of length 2. One this, one this. Similarly, how many subarrays of length 4? So there are 4 subarrays of length 4. One this, and so on. But how many subarrays of length 5? Anyone, how many subarrays of length 5? Anyone? Like up to 4, we saw that it was increasing. So how many subarrays of length 5? Is it 5? Exactly, it is 4 again. So if you look at this, that once you reach this MND, so up to length MND, it was all good. It was increasing by 1. But how many, if I ask you that how many subarrays of length MND plus 1? How many subarrays of length MND plus 1? Then it is not MND plus 1, but it is MND only. See, there are only 4 subarrays of length 5. So this is one subarray, and then you go to this subarray, and it can start here, it can start here, and that's it. So if MND is 4, MXD is 6, and if you want to find out how many subarrays are there of length 5, then there are only 4 subarrays of length 5. So there are only 4 subarrays of length 5. So there are only 4 subarrays of length 5. Similarly, there are only 4 subarrays of length 6. So up to 6 also, there are only 4 subarrays. So now you have reached MXD. If you reach MXD, now it again becomes interesting. So let me do it here. So up to when the length is less than equal to MXD, it is clear. Everyone, Rakesh, Priyansh. Okay, great. So we have seen that when the length is less than equal to MXD, then it's okay. Like up to MND, it was increasing 1 and 1. And after it once reaches MND, then the number of subarrays which I have is basically equal to MND, like it does not increase. But now let me ask you this. I understand that there were many case by case analysis here, so that may make the question a bit messy, but it's all right. So how many subarrays of length 7? Any idea how many subarrays of length 7? How many subarrays of length 7 if you look at this diagram? 3, exactly. So the number of subarrays of length 7 is 3. So this actually gives you a very interesting part. So like if you try to analyze this entire stuff, so okay, just a second. So if I try to make a graph, suppose I try to make a graph, okay, that okay, so this is my value of MND, this is something, and this is my value of MXD, this is something, and I need to find out how many and suppose how many subarrays are there. So I am trying to plot, okay, how many subarrays are there? Okay, so if I'm trying to do this and my k is somewhere here, right? So how many subarrays are there? So first of all, it will try to it will increase till MND. It is a linear increasing curve. For 1, it's 1. For 2, it's 2. For MND, it's MND, right? So it remains MND here. Once it reaches MND, from minimum distance till maximum distance, the number of subarrays do not change. It remains the same, right? And once it reaches MXD, it again tries to starts decreasing, right? And once it reaches k, we will not consider subarrays of length greater than equal to k, so it becomes 0 here. So after that, we do not count anything. So everyone understood how is the curve like getting created? Like what is the how many subarrays you are basically adding up for every length? Okay, great. So that means up to MND. Okay. So what is the maximum length you can create? So if you see the maximum length you can create is, you can never create subarrays of length greater than equal to k. So that is fine. So the number of maximum length you can create is k, but you can also never create a subarray which is length greater than MND plus MXD minus 1, right? So basically the maximum length you can create is minimum of k times MND plus MXD minus 1. Fine. So you can also say that, okay, so that it basically means that if k is very large, then also the maximum length you can create is somewhere here, MND plus MXD minus 1. So you can never create larger than that number of subarrays. So basically, how can I count the total number of subarrays? So basically, there are 3 parts. So we already saw that there are 3 parts of the curve. So it is something like this, then it goes something like this, and then it goes straight downwards. Right? And it may not go to 0. It may not go to 0. So let me erase this. It may be something like this. And then it steeply comes down. I know that this part is my MND, the minimum distance. This part is my maximum distance. And this part, and this value is minimum of k comma MND plus MXD minus 1. So what is the total number of subarrays less than equal to k? We knew that the total number of subarrays less than equal to k here. So here the total number of subarrays is simply MND into MND plus 1. We have already seen this, right? And here the total number, what is the total number of subarrays? It's simply the total if for everything the value is MND here. So there are MND subarrays for every length. And how many lengths do we consider? It's MXD minus MND. Or let's do it like this. Do it like this. We need to find the number of subarrays in this range. So that is basically, let us take all these up to this. We overcount everything. So this is basically MND, because this curve is MND, right? There are MND many lengths here. So it is MND, minimum distance, times this entire length. So that this is basically height times this entire breadth. So that is minimum of, like this entire thing, minimum of K comma MND plus MXD minus 1. So MND into this minus MND. So this gives me this entire thing and minus this part. So what is this part? This part is, again, if you call this difference diff, then this is simply diff into diff plus 1 by 2 and nothing else. So you have to subtract this. So this is how you get the contribution for each and every part. I will probably recommend that you try to understand this by drawing different cases on pen and paper. Then it will be easier. But did you all get the idea? How are we finding the lengths? Okay, fine. So if you look at the code, this is exactly what I've done. I have first found out answer plus equal to MND times MND plus 1 by 2. And then I have found out the remaining entire term and I've multiplied with MND. And then finally I've found out this difference and then I've subtracted this. Okay, so that basically counts the contribution of minimums of all these elements. I do the same for maximums and then I finally return the answer. Okay, so is that fine? Any doubts? Okay, thank you. So that was all for today. If you find any problem or something you would want to recommend, then you could actually fill the feedback form. Thank you. I hope you were able to learn something. Let me end the recording.